Enthusiasm. Now we're going to focus in here on today's lesson. Pretty easy. All right. Again, it is a review. All right, but a really important review. All right. And this week has really important concepts. For those of you guys who are going to challenge yourself, take the SAT again. There's a whole lot on the SAT dealing with equations of lines. So I want to get started. I want you to focus in on what I'm saying. The second time through, you should be better at it. All right, the second time through, you should be better. All right. Now, if you recall, I said slope is simply a rate of change. All right, when you have a line, the slope will always remain the same, which basically means the rise over run will always be the same. Now, does anybody recall last year what the slope formula was? Now, again, that's not a bad thought, but that is the actual equation of a line. Yeah, and we define the slope as m equals y2 minus y1 over x2 minus x1. All right, oftentimes you will see it referred to as delta y over delta x. That is just simply meaning the change in y over the change in x. Also, some of you guys will recall that you will see a lot of teachers talk about simply the rise over the run. The rise over the run. Now again, like I said, please try to focus in here. All right, and listen carefully. This is a really important section, just like tomorrow is a really big section. Today is much easier, so we're just going to do the odds today. But tomorrow and Friday, we're going to spend all day working on equations of lines, which I need for you to master. All right? Now, what we're going to do now, remember, is the rise over run. I always said to start with the leftmost point and work your way to the right, because you read numbers from what? Left to right. So we know right off the bat that the slope for number 1 is what? Negative. All right? Because remember, we're going down the mountain. All right, up the mountain is positive. If you're on a horizontal line, the slope is 0. If you're on a vertical line, it's undefined. Those are the things you should remember. All right, now keep in mind, we're moving from point J all the way to point K. All right, now if I'm moving from J to K, J going down, how far did I go down? 5, right? So we would say down 5. And then I would say I'm moving what? To the right what? To the right 5. Now, remember, delta y, and this down here is considered what? Delta x. So we know now that the slope of that line is simply negative 5 over 5, which is the same as negative 1. Now, does it have to be those two numbers, all right, or those 2 points? And the correct answer is no. Now, again, if you were smart, you could have just said, well, instead of doing that, I prefer to go down 1 and to the what? To the right 1. Would you get the same answer? Yeah. Obviously, negative 1 over 1. So it doesn't matter what 2 points you pick. All right, the ratio will always be the same. The ratio will always be the same. All right, so I know we said we're going to do the odds, but I'm just going to go ahead and jump to number 2 just to review that. All right, from last year, I told you you can think about lines as mountains. All right, skiing down a mountain. All right, that mountain right there would have a slope, we would say, that is undefined, right? The reason why we say it is undefined is because it's a vertical line, all right? Because it's a vertical line. Now, I want to talk to you about how I knew it was a vertical line. I know it's a vertical line, or how I know the slope is undefined. Now, this is what's important. I want you to make sure you write this down. M equals, again, y2 minus y1 over x2 minus x1. A fraction is undefined when the denominator is 0. Listen to what I'm telling you. A number is undefined, or a fraction is undefined when the denominator is 0. So if the denominator is 0, now you got to pay attention. If the denominator is 0, the x2 minus x1, set that equal to 0. So you will always get something undefined when x2 is what? Equal to x1. In other words, if the x values are the same, you will get a line that is vertical. And its slope will be what? Undefined. Now some of you might be thinking, well, how do I know, or why is it undefined? So now just to review, if the denominator is 0, what is 5 divided by 0, for example?
0.
Well, a lot of people think it's 0, but we're going to see if you remember. All right, so the question is this, right? What times 0 is 5? There is nothing. All right, that's why you cannot divide by 0. As opposed to if I did something like this. If I said 0 divided by 5. If you have $0 and we split it up evenly, everybody's going to get what? 0. That's why 0 divided by 5 is 0. Now mathematically it looks like this. 5 times what is 0? Hopefully now you understand the difference, or I refreshed your memory about why something is undefined. Something is undefined when the denominator is 0. A fraction is 0 when the numerator is 0. All right, so in this case, I'm trying to tell you, how do I know that it's a vertical line? I know it's a vertical line when the denominator is 0, which means when the x's are the same. Now look at this vertical line, and I want everybody to tell me what's true about all of the x values. They are the same. If the x values are the same, it is a slope that is undefined. That is essential. All right? Hopefully you understood. Hopefully you were listening. All right, now I want to take a quick look at number 3. All right? So I want someone to briefly tell me, what does delta y equal? Now, I don't really like this one.
Yeah, I'm not a fan.
Right? Because, again, it's kind of difficult to do this one because there's not a, those 2 points aren't exactly on the graph. Does everybody agree? However, if I'm looking at this more carefully, this point right here looks like it's exactly on the graph. Does everybody see that? So I'm going to take a better look at that one. And then I'm going to try to find one that satisfies that. So if I'm looking here, trying to find one, and wow, the one that I'm seeing is the only one up here. Does everybody see that? All right. So again, it doesn't matter what 2 points, all right, but you want to try to find some of the integer values, all right, that are the points, all right, because we don't want to work with the fractions. Plus, there's no way to say exactly what that point is. Now, we might say that we think it's halfway, but we don't know exactly, all right? So when we check now, I want to go for, I want to take a look at this rise from this point here and this run here. So now someone tell me what delta y is.
5.
And what is delta x? 4. So my slope is 5 over 4. I'm agreeing. Very easy. All right. Any questions? Yes.
Why you go left to right?
I did.
Oh.
Right? I started at this point right here.
Why can't you go with
Well, you can do that. So let's look. So that's a very good question, actually. So here and here, right? So again, if you're going to start here, that means when you go down, it's going to be what? Negative. And then when I go to the left, it's going to be what? Negative also. You hear what I'm saying? So it's the same answer.
Okay.
All right? You just have to know what direction you're moving in. All right? So let's take a look now at question number 5. I'm listening. Good.
So if a vertical line is undefined, what's a horizontal?
Somebody tell her horizontal line would be 0. All right, horizontal lines are 0. All right, now let's review here, guys.
Yes, we can skip that.
Parallel. Lines are parallel if what is true?
Same slope.
They have the same slope. All right, parallel lines have the same slopes. Perpendicular, do you remember what the perpendicular lines were? Very good, thank you very much. The opposite reciprocals or negative reciprocals. So here, the slopes would be equal. Slope of line 1 and slope of line 2 would be equal. Perpendicular, we say slope 1 is equal to the negative reciprocal of slope 2. That's kind of how you write that. All right, getting used to writing the proper notation also. All right, that's telling you that if they're perpendicular, the slopes are negative reciprocals. That's all that means. All right, and we'll get into that. All right. Now, it says graph each line to verify your answers. Well, do I really care if you graph the lines? I don't really care. All right, I'm assuming you can graph 2 points. I'm assuming you can connect the dots. All right. So all I care about is determining whether the lines are parallel or perpendicular. All right, so let's take a look at question number 5. All right, so everybody, let's take a look at number 5 real quick. All right. So here we go. For number 5, we're going to say this. The slope of WX is equal to. Now here's where I'm expecting some of you to practice your mental math. 5 minus 4 is what? 4 minus 2 is? So the slope of WX is what? 1/2. That is not difficult. Does anybody have any issues with that? Subtracting the y's and subtracting the x's. Now, just want to show you, if I do 5 minus 4, I must do what? 4 minus 2. If I choose to do 4 minus 5, then I have to do what? 2 minus 4. And now you just get both negatives, right? So I try to keep one positive. All right, that's how I look at it. Doesn't matter what order you do it. It's that you're consistent with your order. All right, now I'm asking to find the slope of YZ. So the slope of YZ would be?
-8 over 4.
Is that right? Just to make sure. All right, just to make sure. And some of you guys are fine with that. That would be -8 over what? 4, which is -2 over 1 or just -2. Is everybody okay with that? Any question? So we would say those two lines are now what? So you would say WX is perpendicular to YZ. That's the symbol for perpendicular. I don't think that's that hard. All right. Okay, let's continue on. So now let's take a look at number 7. So again, the slope of WX would equal, somebody? 3 over
1.
I think 3 over 1 or just 3. Any questions? Now again, they're trying to get and make sure that you understand the positives and negatives, right? When you do the minus and negative, it's plus. Be careful with that. All right, please just follow along with me. I don't think that's that hard. All right, now I'm doing the slope of what? YZ. And that would be, I'm going to go this direction. So that's going to be 9 over 3 or just 3. So now we say the slopes are, the slope of WX is equal to the slope of YZ. Therefore, the lines are what? That's the symbol for parallel. Do I have any questions with that? All right, that's pretty straightforward. All right, now this is this parallel symbol, just 2 slanted lines. All right. All right, now that was 7. Let's take a look at 9. Now it says graph the line that satisfies each condition. Now this I do kind of think that is important. So what I'm going to do now is I'm going to pause, and I have some graph paper for you. I want you to go ahead and use some of the graph paper. I'm probably going to give you 3 or 4 or 5 sheets of graph paper because we're going to continue graphing tomorrow, lines and all that stuff. All right, so I want you to take this. All right, there's several graphs on each paper. Okay, so now that we're back, I want to go ahead and just review with you how to graph just to make sure everybody's in good shape. All right. So it says, graph the line that satisfies each condition. We're going to pass through the point 3, -4. All right, so to pass through the point 3, -4, I'm going to graph 3, -4. I'd like everybody to just go ahead and put a point at 3, -4. Everybody with me on that? It's not a big deal. So it says we want to graph the line that passed through 3, -4 and this parallel. So if it's parallel, I have to find the slope. All right. So the slope of BC is equal to 6 minus 4, which is 2, and 5 minus 2 is 3. So the slope of BC is 2/3. Is everybody with me? All right. So now what we're doing is we're going to this point that we created down here, and we're now going to use the slope of what? 2/3, right? So from there, I just go what?
Up to.
That's beautiful. Up 2 and over 3. All right, and again, like I said, we'll be using our iPads. It'll be easier, but for now, you're old school. Just go ahead and try to sketch the graph as best as you can.
Old school.
What's the matter?
Wouldn't up 2 and over 3 be different?
I'm thinking from here, right?
Oh, that.
From the point. That's a good mistake. All right, it's a good mistake. Remember, good review problem. You're always going from the point that is plotted. You're always going from the point that you plotted. All right, does anybody have any questions? Now, just to show you, or just to make sure that that makes sense, if you want to, we can go ahead and plot the other 2 points, which were 2, 4, and 5, 6. So if I were to plot 2, 4, and 5, 6, let's take a look at that. 2, 1, 2, 3, 4. 2, 4, and 5, 6. Is that what it said? 5, 6 would be right here. And now, if you were to construct that line through those 2 points, then what does it look like?
Parallel.
It looks like they're parallel. All right, now again, that's just a good visual, so you understand exactly what I'm talking about. All right, it's not necessary, but it's just kind of nice to see. All right, lines that are parallel have the same slope. Walker.
How do you get the slope for the bottom?
How did I get? Well, I knew the slope was 2/3. Do you not know that?
Did it say on there?
No, you had to find it. That's what I did over here. The slope of BC is 2/3
Oh, I didn't know.
because I used these 2 points to find the slope. Hey, listen, guys, I want you with me. Concentrate, please. Too many distractions. All right, Walker, is that good now?
Yeah.
Who else had a question? Anybody? Cameron, are you good?
Yeah.
All right. So here we go. Now, I want to take a look at number 11. All right. We're going to graph the line that passes through the point 7, 3. So again, let's everybody plot the point 7, 3. All right. Now what I want to do is, just for time right now, I'm going to go ahead and plot the other 2 points. -2, -3. So I'm going to plot the point -2, -3. And then I'm going to plot the other point, which was -1, 5. And now I'm going to connect those right there so you can get a good visual. All right. Anybody have any questions? That's that line. All right. Now let's figure out what the slope of that line is. All right. So again, the slope of LM is equal to 8. Is that right? Anybody else get 8 over 1?
Yes, sir.
So that slope is equal to 8. All right, now remember, again, right now it's very critical, very critical. So I understand why the slope of LM is 8.
Yes.
All right, now I'm asking you about the slope of the perpendicular line. The slope of the perpendicular line would be
Negative 1/8.
Yes, thank you very much. It would be negative 1/8. Now, from the point that I drew originally, so back over here, guys. So now I'm asking you a question. If I'm going from this point, can I go down 1 and to the right 8? No. Come on now, stay with me. This is the important part. I can't go down 1 and over 8 because I'm out of room. So instead of going down 1, I would have to go what? Up 1, and then going to the right, I would go to the, so up 1 and left 8. So up 1, 1, 2, 3, 4, 5, 6, 7, 8, right here. I think that's where I'm at. Now, what I'm trying to get you to see is, if I were to draw that line, look what type of angle is created. What does that appear to be? A 90-degree angle. That is correct. Or it's a 90-degree angle. So lines are perpendicular if the slopes are negative reciprocals. Yes, ma'am.
What is the pink one?
That was the original 2 points. That's a very good question. Do you want me to show you?
No,
The-
the one from L and F.
Yes, that's exactly right. LM. That's what that is. You hear me?
Yeah. No, it was just wouldn't it be the opposite?
So LM has a slope of 1/8. Do you agree with that or not?
Yeah.
You don't have to now. Remember, come on.
Yeah, I got that.
You with me? So then the slope of the perpendicular would have to be what? You with me now, right? Did I answer your question?
Yeah.
All right. Here we go. Pretty happy with that. Again, it seems like it's coming back. All right, but I know it's been a while, so speak up. All right, anybody? All right, so now that we're done with 11, let's check out 13. All right, so again, on 13, m is equal to delta y over delta x. All right, now again, I'm trying to emphasize, it's better if you start at the left point and go to the right point because you're reading from what? Left to right. So if I start at A and I'm going to B, I would go down
3 press
and then I would go to the right, right?
7. Yeah.
So now when you go down, however, the mistake is that you forget that it's what? Negative. But I always like to try to remind kids that I'm going down the mountain, so that's why it is -3 over what?
7.
-3/7. Any issues? All right. 14, just real quick.
Yeah.
Slope is 0. Come on. Slope is 0. It's not a big deal. All right, now let's take a look at 15.
So he
Rise,
in the rising
overrun. All right. So for 15, the slope is equal to. Come on, help me out. What is it? Everybody agree with 8?
Yes, sir.
All right, so I'm thinking you're correct. Slope is 8. All right, and 17. Slope is undefined. If you recall, slope, undefined. All right, 0 with the line through it. Everybody good with this? All right. Now, those are from just the graphs. Those are looking at the graphs. Now, the next problems, they're just asking you about what? Just the slope. So what was the slope formula again?
Y minus y1 over x.
Y2
Minus y1
over,
x2 minus x1.
thinking pretty good about that.
Oh, let's get
Determine if the lines are parallel or perpendicular. We talked about that. Graph the line that satisfies the conditions. I feel good about that. And I think I asked you to do up to 39, right?
41.
All right, so 41, determine if the lines. Okay, now let's look at 41 real quick. Let me ask you this question because, again, please look up just for a second. If I were to graph this line right here and this line right here, which one is steeper, the one on the left or the right? The left is steeper. All right. Now, if I was making a comparison, which one's steeper?
Right.
One on the right. Now, what I'm trying to explain to you, now please listen because you're going to miss it if you don't. Steeper means what? Greater slope. Do you agree? So, the left is positive or negative? The right is what?
Negative.
But you still told me the one on the right is steeper. Is that true? Right? It's still true, right? Because remember, slope being negative is referring to the direction that you're traveling. Is everybody with me on that? All right, so when you're comparing steepness, the positive or negative really doesn't matter. Is everybody with me? So it is going to be considered the what? You're absolutely correct. You are looking at the absolute value of the slope. But again, I don't need to tell you that. I would hope you would say that's kind of common sense, correct? When you're looking at a mountain, you don't say, I'd rather ski on the one on the left than the one on the right because the one on the right's kind of dangerous. That is steeper, even though it is what? Negative. Everybody with me? So slope, when you're talking about determining which one is steeper, the positive and negative has nothing to do with it. All right, is everybody with me? All right. So I think that's the only thing that might throw you off from there. All right. Now, did I ask you to do 47?
Yes.
Yeah. I want to do 47 because for whatever reason, this seems to be tricky. All right. I'm not sure why it's tricky. All right. So I'm going to do 47 for you, and I'm going to let you do 49 on your own. So everybody take a quick look at 47 right up here. It says, find the value of x or y that satisfies the given condition. I don't care about graphing the line. All right, graphing the line would just confirm what you already know. All right, so I want something to be parallel. So if it's parallel, it must have what? It must have the same slope. So the first thing I want somebody to do is I want somebody to tell me what the slope of 47 is. What is the slope of 47? Yes, so that always reduces to, right, I'm thinking the slope is negative 3/4. Does anybody have any objections to that? I'm doing, by the way, 47 for some of you guys who are joining me now. All right, does everybody agree 47 is negative 3/4? Right? Now, are we talking about parallel lines, right? Then that means the slopes are going to be the same. So this was the hard problem last year on our test. All right? So you have to set it equal to the other slope. Well, the other slope is what? Good. Y minus 1 over 12. Is that correct? Is everybody with me on this? Do you agree we're talking about parallel lines?
Yeah.
So that means the slopes are what? That means the slopes are equal. So I found the slope of the left line, and that came out to be what? Negative 3/4. Now I have to find the slope on the right line, and that just happened to be y minus 1 over 12. Does anybody have any arguments or complaints or not sure about what I'm trying to tell you? All right, now you just do the simple calculation, right? So now here, I would want everybody, come on, look up. I'm trying to show you how you can dazzle your teacher next year. When you cross multiply, what is negative 3 times 12? Then divided by 4. And then add 1. Come on. Negative 3 times 12 divided by 4 is what? Negative 9. And then when you add 1, the value is y equals negative 8. That is kind of how I want you to do that. Now look up on the board and make sure you understand what I'm telling you. You're trying to work on your mental math in class. I want you to be good at that. So look up. Everybody should be able to say, wow, 3 times 12, negative 36. Negative 36 divided by 4, negative 9, plus 1, negative 8. You should all be able to see that. Every one of you. If that's not what you're seeing, let me know. What? Because the equation has a y minus 1. You want me to write that on the board for you? Y minus 1 equals -9. True? When I cross multiply and divide. I multiplied the -3 times the 12, and then I divided it by 4 and set it equal to y minus 1. Good. I want you to tell me if you're not sure about something, because I really want you to be that good at the mental math. All right? You should be able to do that. All right? If not, it just requires what? Practice. All right? Yes, sir.
Where's the 12 come from?
When I did the slope of this line over here. 4 minus -8.
Oh, yeah.
Right? 4 minus -8, which is 12. Anybody else have any questions or concerns? Now look. Yes.
Never mind.
Yes.
Number 27.
Good. Now my next question is, I think I went through everything that might be an issue. I don't think there's a problem. However, somebody was scanning, and they're saying, well, let's double check which one.
Number 27.
So we're going to go back to 27. I feel like everybody should be able to do all of these now, but somebody said I might have an issue with 27. So let's look at 27. All right, a good one to do because it's the what? It's a word problem. So let's see what I can do. I'm just going to get rid of this to give me some room to write. All right, so let's everybody concentrate on 27. This is kind of like an SAT question. All right, you can tell how old this book is because they're using what? It wasn't that fun, right? The good old days. All right. So suppose an MP3 player cost $4.99 in 2003 and $249.99 in 2009. Graph the trend line to predict the MP3 player for 2003 and 2009. All right, so what I'm going to do here is, let me see if I still have this. Well, that was no good. All right. Oh, yeah, it was. All right. So I have to undo that for a second. Sorry. I'm going to graph this real quick. Okay, 27. Here we come. All right, and I got to put it off to the side here because. I don't know why it disappeared. All right, sorry, I'm having a little trouble. Try one more time. All right, now I feel better about it. I got it out of the way, I think. Anyway. All right, here we go. All right, we're going to have to go with that. All right, so it says here that graph the trend line to predict the price in 2003 and 2009. Now, even the problem with my graph here, I don't really like it because really, are there any negative values here, guys? Is everybody with me? There aren't really any negative values. So I want to draw a graph line like this. Everybody good? Right. So then it says in 2003, is that us?
Yeah.
All right, so we'll finish this up tomorrow if you're not sure. All right, but I also posted the solution, kind of look at the solution. All right, sorry, I didn't know we were out of time. All right, listen, that's why I kind of got a little late start today with all the silliness at the beginning. All right.